Hello, Calc class, or Trig class. So we're still working in section 8.1, working with simplifying trig expressions and verifying trig identities. The strategy for each of those things is very similar. And we had this three-step process for trying to verify a trig identity. You can try to turn the complicated side into the simpler looking side if you're given both sides, which you'd have to be if you're doing an identity. And the way you go about that is factoring or forming a common denominator. If you're still stuck, you can try to use a different trig identity. And if that doesn't work, you can try switching everything to sines and cosines. So let's just suppose you do all three of those things and you get stuck anyway. Well, maybe you had problems because you couldn't figure out which was the complicated side and which was the simpler side. Then you can work with each of the sides, not just one of them, but try to turn them into the same thing. So let's try to do that. Let's start with just this left-hand side. Okay, so we'll use the same strategies we were using before when we were trying to simplify expressions. So there's already just one bottom, so you can't really form a common denominator, or it has a common denominator. You could factor the top into tangent times tangent, but that doesn't do a lot. It's not like you got a sum and you're taking the same thing out of everything in the sum. So that's going to leave trying a trig identity. Okay, but the ones with squares on them for all 6 trig functions are the easier ones to use. So we'd try one for the ones with a square on it. And one of them with a square on it, that's going to be one of the Pythagorean ones. That's this one. 1 plus tangent squared is secant squared. The one we're working with right now has a tangent squared in it, so we're going to try this one. So since 1 plus tangent squared is secant squared, we'll replace, so what I'm saying is we're going to use the fact that 1 plus tangent squared is secant squared. So if you solve for tangent squared by itself, that would be tangent squared is secant squared minus 1. So we're going to replace that top with secant squared minus 1. And the bottom is secant x plus 1. Okay, so now we're going to go back. Now that we've decided to use this trig identity, we're going to go back to step 1 again and see if there's something we could do, such as factoring or forming a common denominator. You already have a common denominator, so we're going to try factoring. This says the difference of squares. It's secant squared minus 1 squared, so that means you could factor this into secant of x plus 1 times secant of x minus 1. And the bottom already was secant of x plus 1. So these guys would knock each other out, and you just get secant of x minus 1. Now, one thing I could do is I could try to keep manipulating until I got 1 minus cosine of x divided by cosine of x. Or I could just restart this thing with the right-hand side and see if I can't turn this into that. because if I transform both of them, they end up as the same thing, then the sides would have to be equal to begin with. So let's try that. So now let's work with the right-hand side. Okay. Well, I could distribute this cosine to each term, and then I'd get 1 over cosine minus cosine over cosine. But 1 over cosine, that is secant. 1 over cosine is secant. So this is just secant x minus 1. So these turned into the same thing. So the left-hand side equals the right-hand side, and we verified the identity. All right, let's keep working. This one, when you look at left and right, there's definitely a more complicated side. This is the more complicated side, whereas this one only has one term. So it's easier to turn something complicated into something simple than something simple into something complicated. So I'm going to work with this one to try to create that. And there's different things you can do to start with, but because this guy doesn't have a common denominator, if it was me, then I would try to form a common denominator at the start. Okay, so what I'm lacking in for denominator for the number 1 is a 1 minus sine phi in the denominator. So I'm going to multiply top and bottom by 1 minus sine phi, the second oldest trick in math, so that they have the same denominator. And I haven't changed it because multiplying by 1 doesn't change anything. Okay, now we'll put the numerators together. We'll get cosine of phi, cotangent of phi, minus of 1, minus of the minus would be plus sine, all divided by 1 minus sine of phi. Okay, so I've formed a common denominator, and that's been done. Can't do that again, at least not yet. And there is not a common factor in the top. So what I'm going to do is use a trig identity. I already have cosine here and sine here. This guy is not in terms of cosine or sine, but I think I'll use that strategy of using a trig identity once you've done the common denominator and factoring thing. So we're going to use the cotangent is cosine divided by sine. Okay, so when we stick that in there, we'll get cosine of phi times cosine of phi over the sine of phi minus 1 plus the sine of phi, all divided by 1 minus sine of phi. Okay, now that I've done that to the top, I no longer have a common denominator in the top. So I'm going to make a common denominator in the top before I try to simplify, because that'll help me in general. So this will be cosine squared phi, because cosine times cosine, and then it's divided by sine. I'm going to take this 1, number 1, and multiply it by sine over sine, so that I have a common denominator of sine. And I'm going to take the second sine phi I'm going to multiply it by sine over sine. Then all three terms in the top will be a fraction with sine as its denominator. Okay, now let's put the numerators together that are in the numerator. So we'll get cosine squared phi minus the sine of phi plus sine phi times sine phi is sine squared phi. It's all divided by the sine of phi. You have that common denominator now. And then this guy I'll think of as, because it's just a function, I'll think of it as a fraction by thinking of it as something divided by 1. So then I can flip it and multiply it and not have a function dividing into a fraction, but just have a fraction. Okay, now I recognize cosine squared plus sine squared. That's my first Pythagorean identity. Cosine plus sine squared is 1, so I'm going to use that now. So put the two yellow guys together and you'll get 1 minus, there's still a sine of phi left over. That's it. And you still have a sine of phi, and there's still that 1 minus sine of phi in the bottom. All right, the sine of 1 minus sine phi's cancel, leaving you with just the number 1 in the top, so you get 1 over the sine of phi. But that is the cosecant of phi, and that's what I was supposed to get. So I just turned the complicated guy into the simpler looking guy and verified the identity that way. All right, now let's do, well, we can start on it here. They're telling me to substitute this function. And the expression has x in it, not x over 2. So the first thing I would do is I just multiply both sides of this by 2, and then I'd have 2 sine of theta is equal to x. Okay, so if you put that in there for the x, you'll get that this is equal to 4 minus x squared would actually be 2 sine of theta quantity squared, because I'm putting that in for the x. And then I can distribute the power on the 2 to the 2. 2 squared is 4, and then I still have sine squared, or sine times sine, or sine squared. All right, so that's what I have now. I could factor a 4 out in the inside. That would leave me with 1 minus sine squared. Square root of 4 is being multiplied there, so that means I could take the square root of 4, move it out, and that becomes a 2. And then I have the square root of 1 minus sine squared. Okay, that I recognize as one of our Pythagorean identities again, the one with sine squared in it. So if I were to move sine squared to the other side, I'd get cosine squared is equal to 1 minus sine squared. So what I'm saying is that cosine squared phi plus sine squared phi, oh, this one's theta. Cosine squared theta, sine squared theta. This is the theta letter, is 1. So that makes cosine squared theta equal to 1 minus sine squared theta. So this guy I can just put in cosine squared. And then the square root of cosine squared is just cosine. So that's what you get. All right, that is it for section 8.1. Thank you.